Hello and welcome to this lesson video on defining reflections. Over the course of this whole lesson, we will be looking to have a firm definition for what happens when you reflect a point or a shape across a specific reflection line and what properties it's going to have. To lead into that, to lead into those ideas, we have four figures that we're looking at right now, and we're looking to see which one of them doesn't belong. So you could pick and make a case for any of these figures to say, well, why is this not like the other three figures? So, for instance, in figure one that we're looking at right here, we can see that that figure is different from the other three because that line segment AB going across line L is not going at a perpendicular angle or hitting it at a 90-degree angle. In figure two, what makes that figure two different is that line segment AB is not being split equally in half by line L. You have 4 units and then 6 units on the other side. For figure number 3, we can see that the letters that are no longer A and B for the line segment going across line L, now we have C and C prime. C prime, we mentioned in our last video, is when you have the apostrophe there. So usually C is an original, and then C prime would be after you've changed something. And then lastly, we have figure 4. Figure 4 does not belong with the other three because, unlike the other three, line segment AB is 7 units and 7 units, which would add up to 14 units. The other three figures here that we're looking at are only adding up to 10 units. Now, the idea of the equal sides and the same amount of units total and the perpendicular angle, all of these things will be important when we come to define reflections over the course of this lesson. And that completes our warm-up, our part 1 of this lesson. We are now on part 2 of our defining reflections lesson. And now we are looking at a circle with lots of different points around the outline. And we are trying to kind of answer a question. So the question you can see is in the top left corner. We have triangle GEN has been reflected so that the vertices of its image are labeled points. What is the image of triangle GEN? So you'll notice that I have drawn triangle GEN in purple on our circle already for time constraint. So what I'm looking to do to see if I can get the image after it has been reflected. So in order for us to do this reflection, we need to make sure that we know our line of reflection, and we need to make sure we know where this triangle is going to reflect to, so that all the points are the same distance away from that line of reflection. So now to get that started, we need to kind of read through this, and we're looking for the image. Remember, the image is after the transformation. Pre-image is before the transformation. So if we have this triangle GEN, we need to start figuring out, well, what kind of line of reflection could we find, and where is it going to be located? Because until we know that, we won't necessarily know how to reflect it. So the first thing I would notice is, well, we look on our data card. We have a lot of different bullet points telling us information. The image of this point is that point, and vice versa. So the two things that jump out to me are that the image of G is G, and the image of R is R. You might remember from the lesson prior to this, when you are doing reflections, if you are reflecting a point across a line and the point is on that line of reflection already, it doesn't go anywhere. If it's 0 units away from the line of reflection, it stays 0 units away from the line. So basically, if I were to approach this problem, if I know that the image of G is G, after this reflection, this G is also going to be G prime. So I know that one of my points of my new triangle is going to be at G still. Along those same lines, the image of R is the final bullet point there. So if I were to make this reflection, I would know that R and R prime are the exact same thing. So what that tells me is if I reflected any of these points, the only ones I know for sure that aren't going to move anywhere whatsoever are R and G, and that means that both of those points have to be on my line of reflection because they're going to be 0 units away. So I can take my ruler and I can draw my line from R to G. So essentially what's going to end up happening is that I'm going to have my triangle, my purple triangle, reflect over that blue line that I know here. So I know that G and R are not going to move anywhere. So now I need to figure out what are going to be the images of E and N. So for starters, I can look at my list of points and numbers and everything here. So I can look for either E or N in the list. So I can see that N is U and U is N. So if I have something that's going from reflecting, the image of N is U. That means if I start out at N, I'm going to end up at U. So if I start out at N down here, that means I'm going to end up at U. And you can kind of see how that looks like it's reflecting right across. So this U right here would become N prime. And then I know that I can kind of connect my point G to N, because they're going to be connecting. Since G and N connect over here, they're going to be connecting over here as well. So if I look through my list, I don't see anything mentioning point E, but I need to look at my picture carefully. I can see that U and N are right across from each other, across that line of reflection. G is on itself. So if I compare these points, if I go straight perpendicular down towards that reflection line, the only point it can lead me towards is going to be point J down here. So that means that E prime and J are going to be the same thing. And the image of E is J. That's the ending point. So I can just draw my triangle on this shape now, connecting G to E prime, and then E prime to N prime. And then finally, we can connect our N prime to G. So I have my line of reflection. You can see kind of those marks. That's the line of reflection right there. And given what we knew about images and what we knew about how reflection lines work, we can see that we've reflected the purple triangle over that line of reflection to make our blue triangle. We are now working on problem card number 2 of this same part of the lesson. And in this one, we are looking for some similar things, but this problem says several points have been reflected across a line that goes through 2 of the labeled points. Precisely describe the reflection. Now, if I am going to describe a reflection, I need to know what the line of reflection is first. So if we look carefully at our list of data card bullet points, we see one right here and right here that are going to be important. We know that the image of D is D and the image of N is N. That means that when they are reflected, they are not going anywhere. That means that they are 0 units away from the reflection line, or in other words, right on top of it. So we can plot D, point D, and point N. Those are both on our reflection line, and we're going to connect those points in black on our page here. So now we know what our line of reflection is, and so we need to kind of use that to be able to figure out the entire reflection in this problem. So if I know that I am looking for all these connected points, you can see that A and G, A is reflecting to G, and I is reflecting to V, and you can say J and T, and you can say L and Q, and it's pretty obvious that those are being reflected. So one way you could precisely describe this reflection is, for instance, L and Q, that last one I mentioned, is you could say that point L is reflected over line DN to point Q. So as kind of an emphasis of this, we know that basically the point to its image, if you connect those lines when they're reflected, let's do that first. So we have L and Q are connected to each other. So L and Q. So we can see that that is the reflection. L went towards Q and got reflected from L to Q. But this line that when we connected the pre-image to image, L to Q, this is going to be a perpendicular angle. And we could even measure these two segments. We can measure this segment is 3 centimeters. This segment is 3 centimeters. So they're both equal distances to the line of reflection, and also the line connecting them is perpendicular to our line of reflection. So let's check that with a couple of other points. So let's go back to the top, maybe A and G. So if we do A and G and we connect them, we can see that looks like it's doing the same thing. That looks like a 90-degree angle to me. And if we measure the two segments, we have 3.5 centimeters, and we also have 3.5 centimeters there as well. And just to wrap it up, we can do that with one more pair of points. We'll use one in the middle here. The image of J right here is going to be reflected to T, and so we can reflect and connect the image and pre-image. And we can see that that purple line is a 90-degree angle with its line of reflection from when J was reflected all the way across that line of reflection to point T. And we can measure to see if they're both the same distance from their line of reflection. So you have a little over 4.5 centimeters, and then once again, about 4.5, a little bit more than 4.5 centimeters. So we can see that the main two things we found in both of these problems was that we have a line of reflection where if you have a point on the line of reflection, it's not going anywhere. It's 0 units away from the line of reflection. We've also, that was from the first one. So in this one, we can see that the points, when they're reflected, when G is reflected across this black line to A, they're both the same distance to this line of reflection, ND. And we found that it was perpendicular when you connected that line between the two. So if we want to precisely define this reflection, let's use the points we just used. So we could say point A is reflected across line segment ND, across ND to point G. And we could say that A prime after that reflection would be the same exact thing as point G. So that covers part 2 of this problem, where we're looking at trying to get some more information about reflections. We are now looking at Desmos.com/geometry, which is a geometry construction software easily found through Google. And we are looking at triangle DEC or CDE, however you want to name it. And then we have a line here that's going to end up being our line of reflection. So one neat thing you can do is obviously you can draw shapes and you can draw all kinds of geometric things. But one thing it also do is do transformations. So we are going to transform and reflect, like we've been working on, by choosing our line of reflection and then choosing D as the point we want to reflect. So we have reflected point D right there, and if we click on that new point, we can label it as D prime. In fact, let's make it a capital D for a point of D prime. So we have D prime there, and we know that it is reflected because we have the computer program do the reflection for us. But a way we can confirm that this is definitely a reflection is by using some circles. If you're doing this by hand, you'd use a compass, but we can use geometry software to help us out instead. So we have a circle, and we want to put that circle on our point right here on the line already. And we're going to draw that circle so that the radius, and we can even maybe label this point as, we'll give it just a random letter, point A. So we know the radius of this point A is going to be AD, just connecting these two. So we're going to pick another point on our line up here, and we can draw another circle centered at that point, and we're going to have its radius be D prime. So we can see that we had one circle, and we have basically two different circles where A to D prime and A to D are going to be the radius of this smaller circle, and then we can name this point maybe just point B, and we have a radius from B to D prime and B to D that is equal for both. And we have the circles that we just drew are both intersecting at D and D prime. And that is a great way of finding these reflection points if you don't have the geometry software to make that happen. So let's try that same thing and reflect point E using this software, using a construction. So now we're going to make a circle centered at A and include point E. And then we're going to have another circle at point B, and that one is also hitting point E. And we can place a point, well, obviously it intersects at E. We got that already. And now we also have it intersecting right here. And so we can call that point E prime, now that we know that that is what will end up giving us a reflection point. And we can even transform it, it would end up giving us the same exact place. So we can get rid of this circle if we wanted to. So we can just do this once more really quick, and we can create a point C prime up in this general region so that we can finish off our reflected triangle. So same process, we have one circle centered at B, and this B can be anywhere on the line. So we have that C right there. And then we have another circle starting at A and ending at C. And now we can put a point where it's connecting at C, and then the other connecting point is going to end up being C prime. And we have reflected this whole triangle. So we can get rid of the other two circles. And now we have the points we needed to connect them. So we can just connect all three of these points to make a triangle on this side of the reflection line, so that we have reflected this triangle using circles or a compass if you're doing it by hand, and getting these perfect reflection points. We're looking at a new Desmos geometry workspace now. I've created a line with 2 points on it named A and B, and then a point P. So we're going to do that same reflection method one more time. So we're going to create a circle centered at A, hitting P, and at B, hitting P. And we can place our new point at the intersection of those two circles and label that new point with P prime. And we know that that is reflection, but we want to see, like, well, is it still the same distance to this line AB as point P is? And is it also going, if we connected these two segments, is it going to be a perpendicular line? So let's just connect these 2 points first. So we have P being connected to P. And we want to see if this angle is perpendicular. So if we do point P, and here, that's 90 degrees, and we can do it with any of these other 4 angles, so we can be sure that it is certainly 90 degrees. So now if we wanted to confirm that they're both the same distance away from their line of reflection, we need to use some more tools on that Desmos has to offer. So we'll see if we can make that happen here. So we know we need a point and a point. So if we can select that as its own segment, we can see if we can figure that out. So we can just place a point right there. And so now we know that our line connects right there, and we can just connect with 2 separate segments to that point we've established. So we know that line right there is 3.2 units. And then if we draw another segment, we can draw a segment connecting the middle to point P prime, and we can check to see how long this is, and that is also 3.2. So this is almost everything that is important with lines of reflection, in that we know we have P and its reflection P prime. They're both the same distance away from their line of reflection, and they're also, if you connect them to each other, they make a perpendicular angle with that line of reflection as well. And that covers all the important things we are using Desmos geometry for in this lesson. We are now at the end of this lesson in general, and we want to kind of do a summary before finishing off. The technical definition of reflection is a rigid transformation that takes a point to another point that is the same distance from the given line, is on the other side of the given line, and so that the segment from the original point to the image is perpendicular to the given line. That is a very technical way to put it, but generally speaking, all it's saying is that if you take A and you reflect it over M, it's going to land at A prime. So A to this line and A prime to this line have to be the same distance. So that's what these marks are for. This segment right here is the same length as this segment right here. We also know that if you connect these 2 points to each other, the pre-image and image, the line connecting the 2 of them will be perpendicular to the line you reflected across. And generally speaking, obviously, if you're going to reflect across the line, you're going to reflect it to be on the other side of that line. So that's kind of obvious in itself. But generally speaking, that will apply, all of this will apply no matter what kind of reflection you are doing. And this is whether you're using a grid like graph paper or an isometric grid, or non-grid transformations like we were working on during this lesson. And now we have officially defined what a reflection is. Thank you for watching this lesson on defining reflections, and have a great day.